in the network shown in figure, K is changed from position A to B at t is equal to 0. At t is equal to 0. Solve for I di by dt and d square I by dt square at t is equal to 0 plus. At t is equal to 0 plus. If R is equal to 1000 ohm, L is equal to 1 Henry and C is equal to 1 microfarad and V is equal to 100 volt. Assume that the capacitor is initially uncharged. Assume that capacitor is initially uncharged. So this was asked in one exam for 10 marks. So note down the circuit. This is the circuit. This is the position A and this is the position B and this is the capacitor and it is like this and it is written like this. This is the resistor and then this is the inductor and this is your 100 volt and this is the C and this is your A and this is the B. Okay, and this is the switch K and this is R and this is the L. In the network shown in figure, K is changed from position A to B at t is equal to 0. Solve for I di by dt and d square I by dt square at t is equal to 0 plus. Okay. If R is equal to 1000 ohm, L is equal to 1 Henry and C is equal to 0.1 microfarad and V is equal to 100 volt. Assume that the capacitor is initially uncharged. Here assume that initially it is at t is equal to 0 minus and which position?
Position is
Position A. In that because of 100 volt has given no here, that's why it is fully steady state has been reached. You have to assume like this because earlier at t is equal to 0 minus. So right at t is equal to 0 minus the switch in position A, the position A. So that is switch in this position, A position, and this resistor and inductor will be acts as a short circuit and the current will be flowing in this here inductor. Okay. So this is because if they are given as a 100 volt and it is a resistor is R is equal to 1000 ohm. Okay, and it is a position in a switch A position. Therefore, it is assumed that here the inductor has been steady state has been reached. Therefore, it will be act as a short circuit. Then what is the current flowing in this circuit? No, I of 0 minus it is I of 0 minus is equal to 100 divided by 1000 that is equal to 0.1 amps. Current change inductors will not change immediately, no. Therefore, I of 0 minus and I of 0 plus is also 0.1 amps only. 0.1 amps. Next, a t is equal to 0 plus. Which position at t is equal to 0 plus which position? Which position?
Position B.
Position B. The position B and is given capacitor is initially is uncharged. Therefore, capacitor will be acts as immediately after the closing the switch. Capacitor will be acts as a short circuit now here.
Short circuit.
And current at IL it is whatever the IL it will flow. That is 0.1 amps. It will be flowing, right? And this is your R. This is I of 0 plus. That's why I written I of 0 plus is 0.1 amps. Already written because the same current will be flowing. It will not change immediately. I written already here. This is the concept why it is I of 0 plus is 0.1 amps. Then what is the VC0 minus? What is the VC0 minus? VC0 minus means earlier switch is in the open position and the capacitor is initially uncharged. Therefore, what is the voltage across the capacitor?
0 volt.
0 volt. What is VC0 plus?
0.
Yeah, immediately after throwing the switch, capacitor will be act as a short circuit. If you measure the voltage, then voltage will be 0. Therefore, VC0 minus and VC0 plus will be 0. For t greater than or equal to 0, write a circuit. For t greater than or equal to 0, the switch in a second position. Switch is in second position. So switch is second position means this is opened, and this is no necessity of writing this voltage source because it is opened. So it is connected to like this. The switch in second position, and this is the capacitor here now. This is the capacitor, and this is in second position, and here resistor, and this is the inductor, and here it is C value, and this is the R, and this is the L value. Okay, now apply KVL. They can assume the current as I of t. I of t. Apply KVL for this. Apply KVL. Then you can write it as R into I of t plus L into DIT divided by dt. I will write it R into I of t plus L into dit divided by dt plus 1 by c integral of I of t into dt. Call this equation as a 1. So this is, we can write it as R into I of t plus L into di of t divided by dt plus this is nothing but a voltage across the capacitor, that is equal to 0. At t is equal to 0 plus, at t is equal to 0 plus, this becomes R into I of 0 plus L into di 0 plus divided by dt plus Vc 0 plus is equal to 0. What is the R value? R value is 1000 ohm. 1000 into I of 0 plus is 0.1 amps plus L value is 1 Henry. Di 0 plus divided by dt plus voltage across the capacitor is 0. So therefore di 0 plus divided by dt is equal to how much? Minus
100. Minus 100.
minus
Amps.
100 amps per second. This is the answer. Is it clear?
Yes, sir.
What about diploma students? You have to try to understand the concept. If you are not following, you have to discuss with your friends or ask me. I will explain.
Yes, sir.
You have to work out problem. Don't read this. You have to take a rough sheet and you have to work out the problem. Any doubts? I know it is difficult to follow, but you have to follow. There is no alternate method. Or
Yes, sir.
okay,
Yes.
all of you copied.
Yes, sir.
Yes, sir.
Okay, differentiate equation 1 with respect to t. Differentiate equation 1. Differentiate equation 1 with respect to t. So we get, then we can write it as r into dit by dt plus L into d square I of t by dt square plus 1 by c I of t is equal to 0. At t is equal to 0 plus, this becomes r into di 0 plus divided by dt plus L into d square I of 0 plus divided by dt square plus 1 by c I of 0 plus is equal to 0. R is 1000 and it is di 0 plus is minus 100 plus L is how much, 1 Henry, and d square I of 0 plus divided by dt square plus 1 by what is the c value?
1
1 microfarad.
microfarad.
What?
Zero point 0.1 microfarad into 10 to power of minus
Not
6
point one,
into
sir. Just one.
Sir, it's only 1 microfarad.
a zero point 0.1 microfarad.
Point one.
Note on zero point 0.1 microfarad. C value is equal to zero point 0.1 microfarad. Change in the problem, and I of 0 plus is zero point 0.1 amps. 0.1 is equal to 0. From this calculate what is the value, d square I of 0 plus by d square I of 0 plus divided by dt square is equal to how much?
Sir, is it minus 9 into 10 power 5
Yes,
amps per second?
minus 9 into 10 to the power of 5 amps per second square. Or
Yes.
go to the next problem. No, no. In the circuit of figure shown, in the circuit of figure shown, switch K is closed. Switch K is closed at t is equal to 0. Switch K is closed at t is equal to 0. Find the value of V1, V2, V3 at t is equal to 0 plus. At t is equal to 0 plus. The circuit is initially relaxed. The circuit is initially relaxed. This was asked in one exam for 6 marks. Huh? So this is positive, negative, and this is the switch. Okay, and here it will be a resistor, and this is the capacitor, and here a resistor, and this is your capacitor, and here there will be a inductor. Mhm. This is V of t, okay, and this is the switch, and this is the resistance, and here this is the capacitor here, capacitor, and here resistance, and here it is a capacitor, and here it is a inductance. This is the inductance. This is the resistor, and this is the capacitor. Okay. This is the switch. It is K. This is switch K, and this is your R1, and this is your C1, and this is your R2, and this is L1, and this is the C2, and this is the capacitor. That is voltage across this capacitor is V2, and this is the voltage across the capacitor. This is V3, and this value is C3. This is the C3, and this is the R3. And from here to here, that voltage is a V1. This voltage across this capacitor is a V1. Voltage across the capacitor C1 is a V1, voltage across the capacitor C2 is a V2, and voltage across the capacitor C3 is a V3. Okay, here a T is equal to 0 minus. What happened now here? A T is equal to 0 minus. Switches.
Closed.
It is
In
open.
the
Switch
circuit
is
figure, switch is K is closed at
open.
T is equal to 0. That means opened. It is opened and it is initially uncharged. Therefore, what is the voltage across all the capacitor?
0.
0. So therefore, V1 0 minus is equal to V2 0 minus is equal to V3 0 minus is equal to 0 volt. At T is equal to 0 plus, you are closing the switch. Immediately after the closing the switch, what will happen? Capacitor will be acts as a capacitor acts as a
Open circuit.
Short,
short circuit.
Short
short
circuit.
circuit only, sir.
If you measure the voltage at a short circuit, what is the voltage?
0.
0.
0. Therefore, V1 0 plus is equal to, we are measuring across all the capacitor only. Therefore, that is again it is 0 volt only. This is the answer. For writing this, you will get 6 marks.
That's all, sir.
Huh?
That's it.
Ah, yes. Or
Yes.
okay, take down next problem. In the circuit of figure shown, in the circuit of figure shown, switch K is opened at switch K is opened at t is equal to 0. T is equal to 0.
Can you repeat
In the circuit of figure shown, in the circuit of figure shown, switch K is opened. Switch K is opened at t is equal to 0. At t is equal to 0. Find the values of V dV by dt and d square V by dt square d square V by dt square at t is equal to 0 plus. At t is equal to 0 plus. So this is the circuit. So here it is the switch and the switches. This is the switch is K, and here we connected a one resistor, and here it is connected a one capacitor here like this, and this is where 10 amps, and here the voltage is given as a V, and this is you can take R, this is 100 ohm, and the C value you can take as a 1 microfarad. Work out this problem.
So V of K, we can take it as voltage across resistor only, no sir?
Resistor is parallel. You can take a resistor or a capacitor. So at t is equal to 0 minus here, at t is equal to 0 minus, switch K is what condition?
Close, sir.
Closed. When it is closed means it acts as a short no here. Then
Yes,
what
sir.
is the voltage?
0.
V of 0 minus is
0.
0 volt. Now at t is equal to 0 plus. What is the
Switch is
condition?
open.
Switch is opened, but
Open.
it is at the time of close it is connected parallel no here.
Yes,
Yes,
Parallel
sir.
no. The same voltage will appear at the capacitor no. That means it has the same voltage. Previous what is the VC 0 minus? V is 0 minus is voltage across the capacitor and voltage across the capacitor also. Again at t is equal to 0 plus whatever the voltage no here, because it is connected here capacitor in parallel. Earlier it is capacitor voltage is also 0. Now capacitor voltage is again 0 only. V of 0 plus is again if you measure the voltage will be 0 only. This is V0 plus is also 0. Clear?
sir.
Switch has opened. Okay. Switch has opened at t is equal to 0. Earlier it was closed, short circuit. When it is shorted, voltage across the capacitor is 0. That voltage across the capacitor will not change immediately. Even if you suddenly if you open the switch also, the voltage across that will be 0 only. Therefore, Vf0 minus and Vf0 plus is 0. Clear? Hello.
Yes,
Yes,
sir.
sir.
Cleared.
Okay. Now, a t is equal to 0 plus, a t is equal to 0 plus, switch has opened now. Switch K is opened. Which is the best method here? Huh?
KCL, sir.
KCL. Apply KCL. Apply KCL. Already has given a V no node. You can take this node name as a V only. V means from here to your voltage, from this point to ground point. Already V is there, no? That's why I taken the same name. Now apply the KCL. Current is entering minus 10 plus V by 100 plus what is the volt current for and voltage relationship for the capacitor? What is I?
C dV by dt.
C into dV by dt. I is equal to C into dV by dt. That is equal to 0. Call this equation as a 1. This equation as a 1. Now at t is equal to 0 plus, at t is equal to 0 plus, this becomes minus 10 V of 0 plus divided by 100 plus C into dV 0 plus divided by dt is equal to 0. This is minus 10 plus V of 0 plus is 0 by 100 plus what is the C value? C is 1 microfarad into dv0 plus dv0 plus divided by dt is equal to 0. Then it is dv0 plus divided by dt is equal to
10 into 10 power 6 volts per second.
10 to the power of 7 volts per second.
Yes, sir.
10 to the power of 7 volts per second. Understood this one?
Sir, is d square V by dt square minus 0.1 volt per second square.
D square V by dt square is minus 10 to the power of 11 volt per second square. Differentiate equation 1. Differentiate equation 1 with respect to t. So we get, then we can write it as differentiation of 10 is 0, 0 plus 1 by 100. Differentiation of v is dv by dt plus c into d square v by dt square is equal to 0. At t is equal to 0 plus, at t is equal to 0 plus, this is 1 by 100 dv 0 plus divided by dt plus c into d square v of 0 plus divided by dt square is equal to 0. Now this is 1 by 100 into dv 0 plus by dt is 10 to the power of 7 plus c value is given as a 1 microfarad, 1 into 10 to the power of minus 6 d square v by v of 0 plus divided by dt square is equal to 0. Find out then d square v of 0 plus divided by dt square, how much it is?
Minus
Minus
10 power 11.
11 volts per second
minus
square. Minus 10 to the power of 11 volts per second square. Is it clear?
Yes, sir.
Go to the next. Shall I go to the next problem?
Yes, sir.
Okay. No, no. Determine I di by dt and d square I by dt square at t is equal to 0 plus at t is equal to 0 plus at t is equal to 0 plus when the switch k is closed, when the switch k is closed at t is equal to 0, at t is equal to 0 in the network shown in figure, in the network shown in figure. So this is a diagram. This is your resistor and this is your capacitor. Okay, and this is your 10 volt and this is the switch, it is K, and here this is R is equal to 100 ohm and this is 1 microfarad. Solve this problem. So determine I dA by dt d square I by.
This is I of 0 plus 0.1 amps,
Yes.
and di by dt is minus 10 power 3 amps
Yes.
per second.
Correct. D square I by dt square.
1 minute. Is it 10 power 7 amps per second?
D square I by dt square is 10 to the power of 7 amps per second. All of you get answer, or shall I do it?
Do this one, sir.
Do this. Okay. So determine I dA by dt d square I by dt square at t is equal to 0 plus. Okay, when the switch K is closed at t is equal to 0. So at t is equal to 0 minus
Switch is open.
opened. Okay. So at t is equal to 0 minus switch is opened. Right. Switch is opened. Then what is the I of 0 minus? It is 0
0.
amps. At t is equal to 0 plus. At t is equal to 0 plus. What is the circuit? The circuit will be
Switch
like
is
this.
closed.
Switch is closed, a resistor, and this
Short circuit.
capacitor will be acts as a open circuit.
It's a
Immediately
short
after,
circuit.
Short circuit, sir.
short circuit. Okay. Immediately after the closing the switch, induct capacitor will be acts as a short circuit. Okay. And this is your I of 0 plus. I of 0 plus. Uh, Then what is I of 0 plus now? I of 0 plus is equal to
10 by 100.
voltage. Voltage as given 10 volt. Therefore it is 10 by 100. So therefore it is zero point 0.1 amps. Okay. Now at t greater than equal to 0, at t greater than equal to 0, what is the circuit? This is a switch as closed and resistor, and it is connected to capacitor. Okay, this is our 10 volt, and this is our R is equal to 100 ohm, and C is equal to 1 microfarad, and this is the current, it is I of t. Now apply KVL. When apply the KVL, we can write it as 100 into I of t plus 1 by C integral of I of t into dt is equal to 10. Minus 10 is equal to 0. Okay, minus 10, that is equal to 10. Call this equation as a 1. So this is nothing but 100 into I of t plus this is nothing but a voltage across the capacitor is equal to 10. So at t is equal to 0 plus, this becomes 100 into I of 0 plus this is Vc 0 plus is equal to 10. This is 100 into I of 0 plus is 0.1 plus what is the voltage across the capacitor? Immediately after closing the switch, capacitor will be actually short circuit. Voltage across the capacitor is 0, that is equal to 10. So here you have to find a differentiate. No, here you have to differentiate this expression. Here nothing is to find out here. He has to find out I I of 0 plus is calculated. Then you have to find out di by dt 0 plus d square I by dt square 0 plus, and this is not required here. This is not required here. Differentiate equation 1 here. Differentiate equation 1 with respect to t. Then we can write it as 100 into dit divided by dt plus 1 by c I of t is equal to 0. This you can take this equation 2. Next, at t is equal to 0 plus, this becomes 100 di 0 plus divided by dt plus 1 by c I of 0 plus, that is equal to 0. Now substitute here 100 into di 0 plus divided by dt plus 1 by c value is 1 microfarad into I of 0 plus is 0.1 is equal to 0. From this expression, calculate what is a di 0 plus by dt.
1000, sir. 10 power 3.
Ah, minus, no?
Minus.
Minus 1000, sir.
Minus 1000 or 10 to the power of q. Minus 1000 amps per second. Okay. Again, differentiate equation 2. Differentiate equation 2 with respect to t. We get, differentiate now 100 into d square I of t divided by dt square plus 1 by c. 1 by c, differentiation of it is dit by dt is equal to 0. This is 100. At t is equal to 0 plus, at t is equal to 0 plus 100 d square I of 0 plus divided by dt square plus 1 by c di 0 plus divided by dt is equal to 0. This is 100 into d square I of 0 plus divided by dt square plus 1 by c value is 1 microfarad into di 0 plus is we calculated now here minus 10 to the power of q is equal to 0. So simplify this, di 0 plus divided by dt square is equal to
10
The
power
10 per
7
second
amp per
second square.
7 amps per second square.
Second square.
This is the answer. Calculated. Understood now this? Any doubts?
No, sir.
No, sir. Understood, no?
Yes, sir.
Yes, sir.
Okay. So still 1 minute is there. We'll take the attendance now. Anyhow, it is recorded. Those who want to can download, you can download.